good day. So welcome ulit sa aking video lecture. So for today's topic, we're going to discuss the work and energy. So again, my name is Engineer Brents and I will be your instructor for this topic. So let's proceed with the next page. Ayan. So under session 7, so pang 7 topic na natin to under dynamic of rigid bodies. So we have the work and energy. So in this session, you will get to know more about the concepts of dynamics of rigid bodies and other engineering science. By the end of the session, you should be able to, for number 1, so to develop the principle of work and energy and apply it to solve problems that involve force, velocity, and displacement. Okay, so number 2, so to study the problems that involve power and efficiency. So merong another set of formulas akong hindi discuss regarding this power and efficiency. Pero most probably, especially do sa topic nyo na, or subject nyo na hydraulics, siguro na-encounter nyo na yung formulang to. So same lang din naman siya. So wala naman pinagkaiba. And number 3, to introduce the concept of a conservative force and apply the theorem of conservation of energy to solve the kinetic problem. Okay. So for the lecture part, under the principle of work and energy, so basahin natin yung discussion. So consider the particle in figure 14-7. So guys, this is just the outline. So I told you to read yung sinan kong copy ng lecture. So technically siya yung kabuuan ng libro, yung discussion part. So I only included here the important part or yung equation lang talaga na gagamitin natin. So sa discussion na yan, kaya ako pinabasa sa inyo at pinagawan ko ng outline para at least mag-gets nyo kung tungkol saan ba or ano ba yung concept ni work and energy. Okay, so again, considering this figure, so which is located on the path defined relative to an inertial coordinate system. Ayan. If the particle has a mass m, so hindi lang pinakita dito sa figure, and is subjected to a system of external forces represented by the resultant F sub r. So, due to the external force applied do sa particle mo, so nagkaroon siya ng resultant force denoted by F sub r. So, that is the summation of all forces F. Okay? Then, the equation of motion for the particle in the tangential direction. So, when we say tangential, ito nga siya. Itong F sub t na to. So, that is summation of F sub t is equals the mass times the tangential acceleration or yung a sub t. Okay? So, applying the kinematic equation. So, siguro familiar na sa equation na to. So, saan nga ba ito nanggaling, guys? So, recall lang natin as a review na din. Diba, velocity is the ds over dt and yung acceleration natin is dv over dt. So, when you solve both equation in terms of dt, so, i-cross multiplication mo lang, ang mapapalabas mong equation is ds over v. So, ito is dt. And then, itong isa, kabila, so that is dv over a. So, equate mo lang dt is equals to dt. So, the equation will be ds all over v is equals to dv all over a. So, ads is equals to v dv. And ano ba yung equation na yun? Ayan. So, pinabalang yung yung ds or acceleration is v dv over ds. So, nagkaroon lang dito ng t since tangential acceleration yung kino-consider dito. Okay, so applying the kinematic equation. So, yun nga. And integrating both sides. So, nangyari dito, guys, this equation, ayan. So, yung summation of f sub t is equals to m. So, sinubstitute niya lang yung a sub t with this relationship. So, anong nangyari? So, that will become summation of f sub t is equals to m tapos v dv all over ds. And then, ang nangyari nga lang, itinaas niya dito. So, kaya naging ganito. And then, wala pa pala itong, ito may m na nga. Okay, so, anong sunod nangyari? So, in-integral niya both sides. Ayan. So, the equation now become, ito. So, ito explain rin naman. Assuming initially that the particle has a position of s, which is x sub 1, ito lower limit, and the velocity v is equals to v sub 1. Okay, so the lower limit of both integral side. And later, so yung s mo will become s sub 2, and yung v is the velocity at point 2. So the equation will be like this. Okay? So, ayan. So, magiging m squared. Diba ito is m squared, m constant nga pala yung mass. So, mangyayari, v squared all over 2, yung exponent. Ayan. So, magiging limits of v1 and v2. So, nangyari lang upper limit minus lower limit. So, kaya tayo nag-arrive sa equation na to. And then ito, so from figure 14-7, so balik tayo dito. Note that yung f sub t mo, ito, is equals lang do sa summation of f or yung f sub r multiplied by cosine theta. And so that is acting at angle of theta. Which is correct naman, di ba? So, ang nangyari nga dito is parang ganito siya. Ayan. Ito si f sub t, ito si f sub n, and then ito, yung f sub r mo. And then this is theta. So, yun nga, yung trigonometric function, cosine theta is equals to f sub t all over f sub r. Ayan. So, kung saan nga yung f sub r is equals lang sa f sub t. So, kaya nangyari dito, yun nga, summation of f cosine theta. And since work is defined from equation 14-1, so guys, doon sa first part nung pinasa ko sa inyo na copy ng lecture dito, so this is just an outline. So, ulitin ko lang. So, merong binigay na formula. Ito. So, equation 14-1, kung saan yung work is defined by this equation. So, itong u sub 1 minus 2, 1 to 2, this is that minus. So, this is the resultant work from point 1 up to point 2. Or, this resultant work can be also considered as yung summation ng work natin. Kung saan yung summation ng work is summation ng positive work minus summation ng negative work. So, alam ka naka-consider na positive yung work natin. So, ang work can be considered as positive if yung direction niya is the same as do sa direction ng motion mo. And then, yung negative work, so, yung force is opposite the direction dun sa motion ng iyong particle or object na ina-analyze. So, one example na nakakapag-produce ng negative work is yung ating friction. Okay? So, lagi lang siyang pasalungat. So, yung mga positive work, so, ito yung example nito. Ito yung force na nagkakos para gumalaw ang isang object. For example, papunta sa anan. So, kung meron siyang force na papunta sa anan, that can be classified as a force which contributes to a positive work. Okay? So, now, that equation, yung 14-5 is magiging ganito. So, guys, kahit ito na lang yung sa uluhin natin, So, ito na rin yung gagamitin kong equation. Ang nangyari ko nga lang dito, hindi itong summation ng u of from point 1 to 2. So, ginagamit ko nga is yung summation ng work na positive work is minus negative work. And then, ito, so, pwede mo kasi siyang i-factor out. So, 1/2 of m and then b squared minus b1 squared. Okay, so, para mas-simplify lang natin yung equation na gagamitin. Okay, so, let's proceed with this next discussion. So, baba ko lang na unti. And then, it's sa pa nga pala, as you can see here, yung unit niya na gagamitin natin dito is, ayan. So, force times ds or force times distance. So, the units is in Newton meter, joules, pound feet. Ayan. So, ito, yung m, so that is mass, which is in kilogram. And then, velocity, naka-squared. So, meter squared per second squared. So, we all know that kilogram meter per second squared is Newton. So, may natirang isang meter sa taas. So, which we satisfy the units of both sides. Okay? So, basahin natin yung sunod na paragraph. So, the equation represents the principle of work and energy. So, itong part na to, ito yung work equation. And then ito is the energy equation. So, the term on the left is the sum of the work done by all the forces acting on the particle as the particle moves from point 1 to point 2. So, yun nga. So, itong nasa left side, so ito yung work done by all the forces acting on the particle. So, from point 1 to point 2. So, it's either is it positive or negative work. And then, on the right side, itong two terms na to, so, this is in the form of, yun nga, 1/2 mv squared. Or, itong equation na to is another term sa kanya is yung kinetic energy equation. So, kaya tinawag na work and energy. So, yung right side, that is the energy equation part. So, like work, kinetic energy is a scalar and has a unit of joules. So, that is Newton meter and foot pound or pound feet. However, unlike work, which can be either positive or negative, the kinetic energy is always positive. So, bakit siya laging positive? Okay? So, regardless yung direction ng kanyang velocity. So, tandaan lang, na yung velocity kasi niya is na-squared. Ano? So, di ba kapag pakaliwa, negative. Yung velocity, kung pababa, ganun din. Ano? Or, depende sa, sa initial velocity. Kung susunod siya sa direction ng ano. So, anyway, since na-squared yan, so, di ba, ang negative kapag in-squared mo, positive. So, positive naman kapag in-squared mo, positive pa din. So, regardless of the sign, so, lagi lang din siyang, positive. So, regardless the direction ng motion ng particle. So, it is always positive. So, ito guys, itong equation 14-7, nire-arrange niya lang. Ano? So, under equation 14-16 is applied. This is often expressed in the form na T1, or ito yung kinetic energy at point 1 plus yung summation ng work from point 1 to point 2 is equals dun sa kinetic energy at point 2. Pero, para at isa mabawasan na lang din yung sasaulin, ito na lang yung gamitin natin. Ano? Pero for the sake of the discussion, discuss lang din natin. Itong another form ng 14-6. Okay, so ibaba ko lang. Itas natin ako. Ayan. So, which states that the particle's initial kinetic energy, ito nga, initial kinetic energy, ayan na lang kinetic energy, plus the work done, ito, plus the work done by all forces from its initial position to its final position. So, work from point 1 to point 2. Ito yung part na force times distance. Ito yung 1/2 mv squared. Point 1. And then, ito is equals daw to the particle's final kinetic energy. Ayan. So, as noted from the derivation, the principle of work and energy represents an integrated form. So, dito nagsimula lahat. Nung in-integral natin yung kanyang form na summation of force in the tangential direction is equals to mass times the tangential acceleration. So, obtained by using the kinematic equation, ito nga, VdV over ds is equals to tangential acceleration. As a result, this principle will provide a convenient substitution for summation of f sub t is equals to mass times tangential acceleration when solving those types of kinetic problem, which involve force, velocity, and yung displacement. Okay? So again, kung maalala doon sa ating previous topic, yung kinetics of a particle, di ba yung displacement kapag dinifferentiate mo siya with respect to time, so magiging ds over dt. So velocity na yan. Kasi ito, pag dinifferentiate mo ulit, magiging d squared s all over dt squared, or dv over dt, or equals lang din siya sa acceleration. And so ito yung relationship or yung tawag doon, yung involvement nitong tatlo, yung force, velocity, and displacement, and acceleration. So, si acceleration nga, under sa kinetics of particle. So, dito naman, under work and energy. So, force, displacement, tsaka velocity ngayon. Okay. So, for the application, it is suggested that the following procedures be used. So, this is the procedure for analysis. So, ganito lang din naman yun nasa nando sa module na unang binigay ko sa inyo. So, basahin lang ulit natin. So, for the work, so establish a free body diagram. Establish the inertial coordinate system and draw a free body diagram of the particle in order to account for all the forces that do work on the particle as it moves along its path. So, gagawin mo muna daw ng free body diagram. And then, ayun nga, from initial position up to final position. So, kukuha ulit tayo ng mga relationship nung kanyang mga displacement and also with respect to sa velocity. Next, principle of work and energy. So, apply the principle of work. So, again, itong equation na to ang ginamit for this lecture, pero ang gamitin na lang ulit nga natin is yung summation ng work is equals to 1/2 of m b sub 2 squared minus b1 squared. Okay? So, the kinetic energy at the initial and final point is always positive, regardless nga kung pakaliwa or pakanan, pataas or pababa, since it involves the speed squared. Ayan, a squared naman. A force does work when it moves through a displacement in the direction of the force. So, when we say does work, So ito yung dinidefine ko as positive work. Or in short, sabi nga, it moves through a displacement in the direction of the force. So sumasabay doon sa direction ng force yung displacement or yung paggalaw na particle or object na inanalyze. So work is positive when the force component is in the same sense of direction as its displacement. Otherwise, or vice versa, it is negative. Kung sumaway dito sa condition na to. Next, forces that are function of displacement must be integrated to obtain the work. Graphically, the work is equal to the area under the force displacement curve. Force displacement. Okay. Next, the work of a weight is the product of the weight magnitude and the vertical displacement. So, magbibigay rin ako ng example kung saan meron din kino-consider na vertical translation or yung work with respect to sa weight ng ating particle or system of object na ina-analyze yun yan, yung mga pulley problem. So, it is positive when the weight moves downward. So, ayan, take note na lang din natin ito. So, ang work daw is positive when the weight moves downward. And then, ayun, so tatlong category yung ituturo natin dito. So, yung last, magbibigay din ako ng example ng work for a spring. So, the work of a spring is of the form of U sub S is equals to 1/2 times K times S squared. So, ano ba yung K dito? So, K is the spring stiffness. Okay? So, this is a value. So, most of the time naman, ibinibigay ito. And then, there are cases na it's in the series form or parallel form. So, siguro naka-encounter na kayo ng ganitong problem. Saan kukuha ng value ng K? Depende nga dun sa arrangement ng spring mo. Pero hindi naman magbibigay dito ng ganong case. So, usually, isang type of spring lang naman yung gagamitin. And ibinibigay naman lagi yung value ng K. And S is the stretch or compression of the spring. Okay, so let's start with problem number 1. So, para mas ma-appreciate at mas maunawaan nyo to, gamitin natin or mag-solve tayo ng first problem. Okay guys, so let's start first with problem number 1. So, basahin po natin. A constant force P, which is 750 Newton, acts on a body shown during only the first 6 meters of its motion. So, starting from rest. If coefficient of friction is 0.2, find the velocity of the body after it has moved a total distance of 9 meters. Okay, so ang scenario nito, mukhang walang naibigay na weight ng block. Pero let's just say that this is 1,000 Newton. Okay, so during the first 6 meters, ayan, naka-applied kasi yung ating 750 Newton. So, for this problem, hatiin natin siya into 2 scenario. Ayan. So, during this point, may naka-apply na 750 Newton. So, let's just name this as point 1 up to point 2. And then next, from 6 meters hanggang marating niya yung 9 meter, tinanggal daw yung 750 Newton. Or the 750 Newton force was removed. Okay? Ayan. So, ang total niya, again, is 9 meters. So, what is required in the problem? So, let's name this first as our point 3. So, the required in the problem is to determine the velocity at point 3 or after the 9 meter distance traveled. Okay, so, ano nga yung sabi sa doon sa step-by-step process? So, una nga daw, gawa ka daw muna ng free body diagram. Ayan. So, itong force na to, ayan, 750. So, what other forces is applied in this problem? So, again, yung 1,000 Newton. So, vertically downward or towards the center of the earth. 1,000 Newton. So, lakihan natin ng konti yung agawin. So, since meron kang coefficient of friction, so itong surface na yan, magaspang yan, and given yung kanyang coefficient of friction na 0.2, so, we need to know or determine first the value of the normal force. So, I will name this as my n sub 1 since yung y component ng 750 Newton will affect the value of n sub 1. And magkaaroon tayo ng panibagong n sub 2 pagdating dito. And yung n sub 3. From which yung n sub 3 naman, same value lang ng n sub 2 kasi wala na siyang 750 Newton. So, ang nakaka-affect na lang sa kanya is yung 1,000 Newton load. Okay, so kung may normal force and yung motion nito, because of the 750 Newton, gumalaw nga yung ating block towards or papunta sa kanan or right. So, ang frictional force, again, opposite always the direction. So, I will name this as my frictional force 1. And even though wala ng force dito, ay yung block mo kasi dito at point 2 has its velocity. So, meron pa daw ditong velocity 2. Kaso, again, hindi rin natin alam. So, because of this velocity and since this block is still in motion, so, somehow, meron pa rin siyang frictional force dito. And, eto, meron ka pa rin frictional force at point 3. Hindi pa natin siya alam, but, hindi natin kasi alam if yung at a distance of 9 meters, if gumagalaw pa rin ba yung block natin. Okay? So, yun nga hinahanap. If magkataon kasi na the value here is 0, so therefore, we can say that the block stopped or tumigil na. Ano? Okay, so the point of analysis here. Sige, since I think kompleto na tayo ng given dito. So, dito naman po tayo sa point 2. So, gawan mo lang ulit ng free body diagram. So, unlike sa first free body diagram sa point 1, mas kukunti naman yung force na i-consider natin dito. So, I think yan na yan. Ano? And, so, for point 3, ayan. So, kamukha lang din naman nung sa FBD2. Or almost same lang din ni FBD2. Okay, so once may free body diagram na tayo, so, ang pwede natin gawin is mag work energy equation. Pero before that, mag-statics muna tayo. Ano? So, summation of forces X, summation of forces Y para makuha yung mga unknown. So, point of analysis natin. So, gamitin ko na lang ang color blue. So, at point 1 to point 2. So, first, si SRB part. So, by taking summation of forces Y equals to 0, we can solve for the value of our N1. So, N1 is equal, so ito, so pababa na, transpose sa kabila, yan naging positive. So, 1,000 minus 750 times 3. So, kailangan lang natin is yung Y component over 5. So, what will be the value of our N sub 1? Calcu. Wait lang. Ito ko na lang ilagay yung calcu. So, 1,000 minus 750 times 3 divided by 5. So, the answer is 550. And now, since we have the value of our normal force, we can now solve for the frictional force. So, ano nga yung formula natin for frictional force? Diba mu times n, or that is 0.2 of 550. So, the answer for that is equals to 110. Ayan. So, since we have now all the force, we can now proceed with the DRB part, or for this, yung work energy equation. Okay, so yung summation nga ng work, kung saan yung summation ng work is equal siya sa positive work minus negative work. So, ito yung sa work. And then, para sa kinetic energy, so, di ba 1/2 of the mass times yung B sub 2 squared, or yung velocity after 6 meters travel. So, naka-squared, don't forget squared, and then B1 squared. Okay. Alright, so let's proceed. So, the only force that contribute to a positive work here, or yung same direction nung 6 meter or papunta sa kanan, is the X component of this 750 Newton. So, pakita na rin natin para nakikita ng iba. So, ito kasi, since naka-incline yan, meron siyang dalawang component. So, ito yung x component niya, which is 750 times 3 over 5. So, kung napansin nyo, it is the same direction as the motion of the block. So, therefore, this contributes to a positive work. Correct? So, that is 750 times 3 over 5. So, this is just the force. And then, yung distance traveled, so from point 1 to point 2, so that is 6 meters. So, hindi ko nalagay yung unit. Okay, so aside from that, meron pa bang force? So, wala na. Ano? Next na force na gagamitin natin is yung frictional force. So, since opposite yung direction niya or papunta siya sa kaliwa, therefore, that can be classified as a negative work. Or minus 110 times 6. So, meron pa ba? So, wala na. Ano? So, equals to 1/2. Ngayon, mas yung given, ano sa ating problem. Pero ang given sa problem is naka-weight. So, to get the value of its mass, so yung 1,000 Newton, simply divided by 9.81 to make it in kilogram. Okay, so V sub 2 squared. So, ano yung ating initial velocity? So, from the problem itself, ang sabi dyan, it starts from rest. So, under kinematics, when we start from rest, therefore, the initial velocity is 0 meter per second. Therefore, I can cancel out this one. So, pwede kong gawin dito. Tanggalin ko na to. And then, isara ko na yung equation. So, I think, makukuha na natin yung B sub 2. So, pindutin lang po natin sa calculator. 750 times 3 divided by 5 times 6 minus 110 times 6 times 2 times 9.81 and then divided by 1,000 and then square root of the answer. So the velocity is 6.3265. So meter per second. So hindi pa ito yung required. Next, from point 2 to point 3 naman. Okay. So, ganun ulit. We need to identify first or to solve first for the value of the normal force. Pero kahit ito naman ay titig method lang, kasi kapag nagsummation ka ng forces ng y, ano yung magiging value ng ating n sub 2? So, di ba equals lang din siya sa 1,000? And then ito, so that is 0.2 of 1,000 or that is 0.2 times 1,000, so that is 200. Tama ba? 0.2 times 1,000. Tama yan. Ayan. Sige, so, meron na tayo. So, diretso na tayo sa summation ng work. Ano? So, again, ito is from point 1 to point 2. So, this time, summation tayo ng work. So, from point 2 to point 3 na. Is equals to 1/2 of the mass. So, B sub 3 squared minus B sub 2 squared. Okay, so, considering this diagram, is there a force which contributes to a positive work? So, wala na, di ba? So, puro negative work na siya. So, that is 200 lang times yung distance niya na 3 meters. Okay. So, negative to. Kasi negative work nga. So, minus. So, wala na, no? So, pwede nating equals to 1/2 of the mass. Again, divide it by 9.81. And then, V sub 3, ito nga yung unknown. So, minus yung nakuha nating sagot na 6.3265 squared. So, we will have an answer for the velocity under point 3. So, pindutin lang natin sa calculus. Negative 200 times 3. So, 1/2 times 1,000 divided by 9.81 times the quantity of ayan, squared minus 6.3265 squared. So, shift solve na lang natin. Lagyan natin positive value. Ayan. So the answer is 5.3153. Ayan. So, meter per second. Okay, so i-check natin siya. Ito kasi, ang ginawa ko, hinati ko siya to two segment. Pero, pwede mo kasing gawin, pwedeng isang ano na, from point 1 to point 3 na. Okay? So, check natin if pareho lang nalalabas na sagot. Okay, so check natin. Green ko na lang dito. So, this is for the alternative solution. So, considering from point 1 to point 3, again, the summation ng work is equals to 1/2 of m, so b sub 3 squared na minus b sub 1 squared. Squared. So, guys, ito nga, ang ating initial velocity is 0. So, therefore, I can cancel out that one. So, yung positive work natin, ito. So, sulat lang natin siya. So, yung 750, yung x component niya, 3/5, multiply by the distance. So, hindi mo siya isasagad na 9 ha, kasi nga, ang condition natin is yung 750 is hanggang maarating lang siya sa 6 meters. After no 6 meters na wala siya, so itong distance na to is 6. Okay? So, ngayon, meron ka ditong frictional force. So, minus, yung frictional force at point 1, 110. So, multiply mo lang din ang distance sa 6. Kasi from point 6 to, from 6 meters to 9 meters, iba yung value ng frictional force niya. Kasi nga, nawala yung ating 750. So, ito, dugsungan lang natin. So, dito na lang sa baba. So, minus yung 200. Ngayon, yung distance na travel niya is from this point up to this point, which is 3 meters. Ayan. So, equals to 1/2 of the mass na 1,000 divided by 9.81 and then b sub 3 squared. So, what is the value of b sub 3? Ito na lang sa LQ. So, 750 times 3 divided by 5 times 6 minus 110 times 6 minus 200 times 3 and then gawin ko times 2 times 9.81. Ano lang ha, tinaas ko lang ito sa kabila. Tapos divided by 1,000. And then square root of the answer kasi naka-squared siya. Transpose ko sa kabila. So 5.3153. Ayan, pareho naman. So 5.3153. Okay, so itong solution na to maganda if direct naman yung pinapahanap na sa 9 meters lang. So ang advantage naman nito kapag hindi lang yung velocity at 9 meters yung pinapahanap sa prob. Kumbaga by segment by segment. So ayan, yan yung dalawang way para i-solve siya. So madali lang naman ano. So again, I'll give you 3 minutes to copy the solution. So you may start copying. Okay guys, so let's proceed with the next problem. Okay, so problem number 2. So basahin po natin. Saan yung aking? A block resting on an inclined plane with slope of 3 vertical, 4 horizontal has moved 3 meters from rest due to the constant force P of 600 Newton and was removed. Find the velocity of the block when it returns to its initial position. Okay guys, so ayun nga, wala siyang binigay na figure. So, alam muna natin siyang interpret or i-drawing. So, meron daw ditong inclined plane. And then, yung slope niya is given as 3 vertical, 4 horizontal. So, ito, obviously, 5 siya. So, ngayon, meron ditong block. Which is, wala na namang weight. So, sabi dito sa libro, so this is a 500 Newton block. Ayan. So, a block resting on an inclined plane with a slope has moved 3 meters from rest to the dock. Okay, so yung force P dito, ayan. So, wala naman sinabi na naka-inclined siya or kumbaga pa ganito yung kanyang direction. So, wala namang angle na binigay. So, I assume na acting along the parallel. So, meron nga daw ditong P which is 600 Newton. So, because of this force na 600 Newton, gumalaw daw po yung block natin ng 3 meters. So, kung gagawin mo dito ng axis, palitan natin ang kulay para maganda. So, dito ko na lang sulat. So, this is point 1 and this is point 2. A block is resting on an inclined plane. Okay. So, tatravel pa to. So, ito yung block mo. Ayan. So, parang kapareho lang to nung previous problem natin kanina. Ano nangyari nga lang? Naka-incline siya. So, tinanggal yung 600 Newton and then eto, meron ulit siyang velocity 0. So, a block resting, kaya 0 siya. Yung B sub 2 natin, so kagaya kanina, unknown siya. So, nawala nga yung ano. So, ang only force na nag-act dito is yung weight niya. So, since meron siyang velocity dito, hindi natin alam, pero alam ko may value siya ng velocity. Meaning, magta-travel pa yung block natin. Ayan. So, kagaya nun, hindi rin natin alam kung ano yung distance na ito. So, sabihin ko na lang siya as S sub 2. Hindi, S na lang. Wala namang. Ayan. So, find the velocity of... Ayun. So, ito pala, parang concept nito guys is yung vertical translation. So, narating kasi niya yung maximum height niya. Ibig sabihin dito, nung narating niya itong point na to, itong point 3 na to, tumigil na siya eh. Or anong nangyari? Yung velocity niya pagdating dito sa point na to is 0 velocity. Diba? Parang siya. Momentarily, mag-stop siya dito sa point na to. Ang hinahanap kasi dito, find the velocity of the block when it returns to its initial position. So, from this point, syempre, tumigil na. So, because of the gravity, bababa naman ulit siya papunta doon. Ano? So, tinatanong niya, ano yung naging velocity niya nung nag-arrive siya ulit dito sa initial position niya. Okay, so dalawang scenario. So, ang sunod kong gagawin is magdodrawing ulit ako. So, ang mangyayari, ito na yung initial point ko. Tapos yung final position niya is yung original position niya kanina. Ano? So, mangyayari, ito yung magiging point 1 ko sa sunod kong analysis. So, kailangan ko munang hanapin yung mga S dyan. Ano? Yung distance traveled. So, this will be my point 1 and ito na yung magiging point 2 ko. So, ito is unknown. Hinahanap yan. Kung saan yan equals sa 3 plus S. So, hanapin muna natin yung S. Okay? So, yan. At least, na-identify na natin kung ano yung magiging system ng solution natin dito. Yung pag-aasunod-sunod. So, ang gagawin ko yung hindi na baak-baak method. So, diretso na ko na from point 1 to point 3. Okay? So, sulat mo lang yung equation. Summation of work is equals to 1/2 of the mass. So, yung velocity niya at 3 seconds squared. So, wala na pala tong right side of the equation. Tama ba? Kasi 0, 0 eh. So, wala na to. So, ito na lang yung kailangan nating malaman. Kaso, wala pa pala tayong mga force. Ano? So, yung weight mo, ayan. So, this is 500 Newton. So, ito 3, 4, 5. So, ang mangyayari, ito yung 3, ito yung 4, ito yung 5. So, again, may friction ba? Kulang-kulang yung given. Silip lang ako Micael, may value na naman yung ano natin. So, yung coefficient of friction dito, guys, 0.2. So, 0.2. So, kailangan nga natin munang kumuha ng normal force at point 1. And then, since pataas yung movement niya, motion, so, ang frictional force niya is going pababa. Okay, so at this point, eto, meron ka ditong weight. Yung pa din naman yun, hindi naman sinabing gumaan. So, dito may normal force at point 2 ka, and then frictional force at point 2. Okay, so hindi pa pala tayo makapag-summation ng work. Mag-SRB muna tayo. So, when you take summation of forces, so mag-shifting ng axis. So, ito yung magiging X, ito yung magiging y-axis ko. So, assuming in this direction, as positive, take summation of forces y equals to 0. So, N1 is equals to 500 times 4 over 5. So, this is 400. And then, yung frictional force niya, so, multiply mo lang ito ng 0.2, 80 nga ba? Magbuti na nakakasigurado tayo. So, frictional force. So, 0.2 ng 400 is equals to 80 Newton. Ayan. So, dito naman, ganun din, hindi naman naka-affect kasi ito kasi this 600 Newton is acting along the inclined plane. So, hindi siya nakakontribute dito sa summation ng forces y. Unlike do sa first problem natin. So, which is, mas madali naman to. Hindi pala. Dumali ngayon kasi nga, eto, wala naging effect dito. So, kung ano yung normal force natin dito, ito na lang din yun. Equals lang din siya sa N1. And then, equals din sa frictional force at point 1. Ayan, so we can now take summation of forces ng summation ng work. So, ang positive work lang dito is yung 600. So, 600 times the distance of 3. And then, plus yung frictional force natin na 80 times distance of 3. So, ito muna yung tinitingnan ko. And then, eto. So, kung titingnan nyo ito mabuti, the x component of weight mo contributes to negative work. So, 500 times 3 over 5. Okay, so, minus, but ito plus, frictional force to eh. So, this is supposedly supposed to be minus 80 times 3. Okay? So, minus yung x component ng weight na 500. Nagbabagal na naman. Times 3 over 5 multiply by the distance of 3. Okay? So, we're done na ha at this point. So, ang sunod naman, pa tayo dito sa kabila. So, from point 2 to point 3. Nasa work pa rin tayo ha. So, again, yung frictional force mo, meron pa rin siya dito hanggang marating siya sa point dito. So, minus 80 and then multiply by the distance of S. Ito nga yung hinahanap. S ko mukhang 5 eh. Hindi natin ayan. Okay, so baka lang kasi malito kaya ginawa ko ng baba. So, minus, so again, yung x component ng weight, i-consider pa rin natin. So, minus 500 times 3 over 5 multiply by yung s, yung palang dollar, is equals to 0. And so, with this, ma-compute natin yung kanyang distance s. So, 600 times 3 minus 80 times 3 minus 500 times 3 divide 5 times 3 3 divide 5 times 3. So, bantayan nyo yung pindot nyo minus 80 is x minus 500 times 3 divide 5 times x shift solve. So, i-0. So, yung S na travel niya is 1.7368. 1.7368 meters. Okay, so now, we can now analyze it. So, from this point, yung nasa peak na siya, sabihin na nating peak yan, pabalik doon sa kanyang original position. So, since meron na tayong value ng S, ma-compute na natin yun, velocity niya. Pagbalik niya doon sa kanyang initial position. Okay, so, balik na tayo dito. So, now, considering, lagyan natin prime to para naman may distinction siya sa dulo ko talaga na. Ayan. So, considering 1 prime to 2 prime. So, dito, ang mga forces na i-consider natin, again, is yung weight niya, which is 500 Newton. So, since bababa na siya, guys, yung frictional force niya, so, motion niya kasi is pa ganun na. Diba? And knowing na ang initial velocity niya is equals to 0 kasi nagsimula nga siya sa peak, ang hinahanap is yung velocity niya dito, B2 prime. Yung bumalik siya dito sa original position niya. So, the frictional force is papaganito. Pasalungat ka lagi. Frictional force. 1 prime. So, again, ito naman yung normal force mo. Kung saan yung normal force, so 500. So, ganun lang din naman yun. Times 4 over 5. So, 400. Yung FF prime, so pareho lang din doon sa kanina. 80 pa rin naman siya. And there's no indication naman, wala naman sinabi sa problem na nagkaroon ng another horizontal force nung pababa. So, yun pa rin yun. So, sige. I think we can now solve this one. So, again, summation ng work is equals to 1/2 of the mass So, b2 prime squared minus b1 prime squared. Kung saan yung initial velocity niya nga dito is equals to 0 na. Okay, so since pa ganito yung movement niya, therefore, yung x component ni weight, di ba yung x component nito is going in this direction. So, sumabay siya doon sa velocity doon sa movement ng block natin. Therefore, it contributes to a positive work. So, ibig sabihin yan, yung 500, so paano nga makuha yung x component? So, di ba ito ay 3, 4, 5. So, times 3 over 5 multiply by the distance of, so ano yung distance na to? So, that is just the sum of 3 plus s, yung dollar na to. Or that is equals to, so 3 plus 1.7368, so that is 4.7368. Ayan na. Inad ko lang dito sa 3. Wag malilito. So, pag ganun, okay. So, meron pa bang force? So, yung frictional force na lang. So, since pa opposite siya dun direction, so, minus 80 times yung distance na 4.7368 is equals to 1/2. So, 500 divided by 9.81. Kita pa ba sa OBS? Wala na. So, ano ko na lang dito sa baba. Inipat ko po sa baba. So, equals to 1/2 of 500. So, again, naka-Newton siya. Divide mo ng 9.81 to make it mass. And then, yung velocity 2 prime squared. Ayan. So, what is our velocity when it returns to its original position? So, pinadala lang sa akin. So, 500 times 3 divided by 5 times 4.7368 minus 80 times 4.7368. Okay, so times 2 times 9.81, then divided by 500, and then square root of the answer, which is 6.3947 meter per second. 3947. Ayan. Alright guys, I'll just check. Ayan, tama naman. 6.4 dun sa book. So again guys, I'll give you 3 minutes to copy the solution. So you may start copying. So ano guys, 'di ba? Madali lang naman siya kung tutuusin kasi ito lang yung equation na nadagdag dito di ba? The rest yung application niya, parang ang mas lumamang na ngayon dito yung SRB kasi free body diagram ulit tayo. Summation forces X, summation forces Y. So in the part of DRB, ito lang talaga yung natin. Yung force, yung work naman, nag-work na rin tayo before. Force times distance lang. Itong kinetic energy siguro yung bago, no? 1/2 mv squared. Pero P6, potential kinetic. Okay guys, so let's proceed with the next problem.